Snowflake. What is Snowflake? Snowflake is one type of database which will call it as a centralized repository which will store the data coming from different range of sources. Snowflake is one type of database only, but it is called as a centralized repository which will store the data coming from different range of sources. Huge and bulk of data also you can store. Historical data, for analytical purpose we'll use this data warehouse. So data warehouse are multiple products we have in the data warehouse. Multiple products you have in the data warehouse. Even database you can use as a data warehouse also. Like Microsoft SQL data warehouse is also available. Microsoft SQL database is also available. You can use your database as a data warehouse. Now, there we have multiple products in the data warehouses. But data warehouse is exclusively used to maintain huge and bulk of data. For that, you need huge and bulk of storage. Now, then Snowflake is the one of the cloud data warehouse. Snowflake is the one of the cloud data warehouse. Now here, two words we have: cloud and data warehouse. Now tell me, what is data warehouse? Data warehouse is a one type of database which will store huge and bulk of data into the centralized repository, which will come from the different range of sources. Then what is cloud? Anybody knows about the cloud? What is cloud? Anybody knows about it? Anybody knows about it? Cloud?
So cloud is like the place where you get the services, means on the pay-to-go model, rather than on the on-premise where we don't get such service. Like if you are buying, we are buying as a physical server, but in the cloud you get those as an virtual machines, and the two there is an auto scaling possible with respect to the services that we wanna use on the day-to-day life.
Yes, absolutely right. Absolutely right. So the cloud is nothing but all the resources are maintained on the some other place via internet. You are accessing that resources like computer, router, switches, IoT devices, sensors, websites, applications, whatever it may be. All will be placed on one place, and via internet, users are going and accessing that resources. That refers to cloud. Actually, after the usage, monthly bill will come. So after that only you will pay the money. Based on your usage only you need to pay your money. So that is called cloud model. Whereas on-premises means all the resources was maintained on your premises only, in company itself. So you need to purchase, you need to do everything, okay, on-premises. So further that we call it as a on-premises. So that which is best one? Which is best one?
As we pay for whatever we use, cloud is the best one.
Yes. Cloud is the best one. Why? Because there is a lot of drawbacks in on-premises. There is a lot of drawbacks in on-premises. First one is, let's say for example, you purchase 100 physical servers. You invest a lot of money to purchase 100 physical servers. But these 100 physical servers needs to take more time to install operating systems and so drivers and so applications. Time taken process to install it. First point is time taken. And the second point is need to invest more money to purchase 100 servers, first of all. That's the second point. And the third point is, let's say you purchase 100 servers today. Okay. Unfortunately, these 100 servers are not sufficient for your usage. Then tell me what you need to do. You need to purchase more servers. That means limitation is there. For 100 servers means 100 servers you need to use. There is no possibility to go more than that. Again, you need to invest more money. So that is another one. Limitation is there. And the third point is, let's say today you purchase 100 servers, but you are using only 50 servers. Then what about the remaining 50 servers? That are waste of resources. Waste of resources at the time of ideal duration, ideal period. Sometimes some people, sometimes the actions are not happened that much of frequency. The traffic is not that much of frequency. So at that time, these wastage is happened in the ideal period. Ideal period. That is the fourth point. And the fifth point, like maintenance overhead, everything will be taken care by you only. Climate control, electricity, everything, patches, everything will be taken care by you only. And next point is latency issue. Let's say you set up your data center in India. Some people are searching from the USA, so they will get some latency issues to search the data. Latency issues to search the data. That is the sixth point. And the seventh point, no disaster recovery. No disaster recovery. If anything happens to that particular data center, there is no disaster recovery. These all are the most common problems we are facing on premises. That's why people are more attractive on cloud. Why? Because no maintenance overhead, no time taken installation. Why? Because image will be run immediately within the span of seconds. The account will be created and operating system will be installed and drivers will be installed. Supporting drivers will be also installed. And somewhere you'll get a packages with applications also. Like for example, Windows with Java, Windows with Linux with Java packages also will get. And also infinity scaling for storage point of view, for computing point of view, infinity scaling. You can go beyond your usage. And also you can go no maintenance overhead, everything will be taken care by you only. No waste of resources also. Why? Because how much of you are going to usage. Based on your usage only, you need to pay the money after the end. After the usage only, you need to pay as you go. Okay. Pay as you use. How much resources you are using, for that only you will pay end of the month. This is the major impact. Disaster recovery is also available. Let's say they will provide a availability jobs. If anything happened to the one availability job, our data is fully secured and available in the other job. These are the most important points. We are going with cloud. Clear? Yes, sir. Yes or no? Can you please respond?
Yeah, it is clear.
Now, cloud you understand. Now data warehouse. Now tell me, data warehouse. If you do data warehouse operations, what you need? If you want to do data warehouse operations, what you need to do? What we need majorly? What we need, sir? Majorly?
A data processing tool and the data warehouse or database to store the data.
Okay, processing means computer. You need compute. Yes?
Yeah.
And storing means you need a storage. Clear? That means I need a compute and I need a storage. Whereas this compute and this storage will be coming from AWS Cloud, Azure, GCP. Cloud vendors. Provided by AWS, Azure, GCP, cloud vendors, any one of it. So for data warehouse, computing and storage is needed, but the computing and storage will be provided by a major cloud vendors like AWS, Azure, GCP, cloud vendors. Okay, major cloud vendors like cloud vendors like GCP. Okay, got my point? Cloud vendors for this. Cloud vendors, AWS, Azure, GCP. Got my point? For data warehouse, Snowflake data warehouse. I'm just saying that data warehouse, compute and storage is needed. Okay, fine. That computing and storage will be on the on-premises means, let's say example is Hadoop. Hadoop. Let's say this also needs a Hadoop data warehouse. Hadoop data warehouse. For this is an example of compute and storage. So this is on-prem. Got my point? So in this case, cloud data warehouse examples are one, Snowflake, and second one, Redshift, Amazon Redshift. Third one is Microsoft Azure Synopsys. Microsoft Azure Synopsys. Fourth one, BigQuery, Google BigQuery. And the fifth one, Teradata. For them, for storage and computing, for these guys, own storage and own computing. Why? Because they are having a own cloud now. Own cloud will provide for storage and computing for SNC. Same like that. Here also own. Here also own. But for Snowflake, all three vendors will support. All three AWS, Azure, GCP will supports for yes, see. Got my point? Yes, sir. Please respond. So now, if it is a Snowflake data warehouse, Snowflake cloud data warehouse, so for Snowflake, the storage and computing are provided by third-party vendors like AWS, Azure, and GCP. That's why this data warehouse, Snowflake call it as a cloud data warehouse. Cloud data warehouse. Got my point? So now one thing you need to remember on the cloud, whereas computer and storage, both are independent things. Both are independent things. So in the on-premises, both will come under one node itself. Let's say, for example, here itself, they will get a one node like this. So in the on-prem, let's say this is computer. For example, CPU and RAM. Okay, CPU and RAM. And this is ROM. ROM means storage, whereas this is a computing. This is a compute, and this is a compute, and this is a storage. Now in the cloud, both are different. Both are independent, not dependent. Not dependent. So both are independent. Both are independent, not dependent. Let's say in the cloud, in the on-premises, what will happen means, if you want to increase a CPU and RAM, you can increase for both. You need to increase both. Hardware requirements will be completely changed based on the requirements. Okay, reconfiguration will be happen same, like a completely one will come like this. You need to increase like this. In the on-prem. Got my point? On-prem. Let's say if you want to increase more, you can increase more. Like, so in the cloud, not like that. The cloud, not like that. If you want to increase, you can increase the computer. If you want to increase more on computer, you can increase your more on computer. If you want to increase more on computer, you can increase on more on. If you want to increase storage, you can increase the storage individual. This is very independent. This is a dependent actually. In the on-prem, on-prem, in on-prem, compute and storage are dependent for each other. Whereas in cloud, compute and storage are independent for each other. Independent. Got my point? Online people. That got my point or not? That got my point or not? Please respond. Hello.
Yes, we got your point.
That good. That's good. That sounds good. So now, for clear understanding, let's say, for example, I'll tell you one example. Let's I ask you X person about alphabets, about first four alphabets. Okay, first four alphabets. What is the answer? A, B, C, D. Answer is A, B, C. I ask the Y person in this scenario. As the Y person about person about below calculation. So that is, for example, A equals to 2, B equals to 3, and C equals to A plus B. Now what is C? The answer is tell me 5. Now tell me where this answer will get and where this which storage you will get from this answer and this which storage will get. This answer is from permanent storages. Permanent storages. And this answer is from temporary storages. Yes or no? So why? Because you don't want to need to store A equals to 2 equals to B equals to C for entire your life. It is a temporary purpose. So you don't say that answer equals C equals to 5 for entire your life. It is for the temporary purpose. Yes or no? So there we
Yes.
are. For saying C equals to 5 is permanent storage is necessary. For saying 5, for giving note, for giving answer C equals to 5 is permanent storage is necessary. Please tell me. Permanent storage is necessary. Answer is no, sir. No. So why? Because we can have a CPU plus RAM. RAM is a temporary storage. So with the help of CPU for computing, it is a computing operation. With the help of RAM, see, actually RAM means a temporary storage. Actually, RAM is a temporary. CPU having a temporary storage. With the temporary storage, so we can. This is ROM actually. ROM. This is RAM. Or ROM or hard disk, external hard disk, storages basically, external storages. We can call. Clear? For giving an answer c equals to pi, is permanent storage is necessary? No. Why? Because with the temporary storage, you can process our data. But for giving A, B, C, D answer, why? Because you are checking, you are storing the data from childhood onwards, you are storing the data in permanent storage. Yes, for permanent storage. So for giving the permanent storage answer, we need a computer power also. And also temporary storage also needed. You'll get back to the temporary storage and it will say that answer A, B, C, D. Clear? Any question? Please tell me any questions do you have? Any questions you have, sir?
No.
Hello.
I don't have any questions.
Next. As we said that here a computer means computing plus temporary storage, whereas permanent storage is. So this computing and storage will be allocated to Snowflake in the form of cloud vendors, AWS, Azure, and GCP. AWS and Azure and GCP. So that everywhere Snowflake will take care about the how much of computer power needs to be taken. Only computer and storage was provided by cloud vendors, and every option will be taken care by Snowflake only. Like how many computers you want, how much of storage you want, how to search your data, everything will be taken care by this Snowflake only. Let's say how many computers you want, that will be defined in the form of virtual warehouse. Virtual warehouse in the computer power. Virtual warehouse is a computer power in the form of clusters. Okay. So whereas how the data will be searchable from that storage with the help of metadata. Anybody knows about the raw data and metadata? What is the difference between metadata and raw data? What is the difference between metadata and raw data? What is the difference between raw data and metadata? Anybody knows? If you don't know, please tell me. I will explain. Actually, raw data means actual data. Actual data. Let's say you have a table. So the table consists of a let's say this is a table. The table consists of C1, C2, and C3. And these all are the records. This entire table records we have, all this we call it as a raw data. Raw data. Then what is metadata? Metadata means what is the table and how many rows, how many records you have in the table, and what time it was created, by whom it was created, and where it was created, and what purpose it was created, and what is the schema for the table. That is entirely metadata. That is entirely metadata. Let's say you have a one image, sir. That image we call it as a raw data. So what about the metadata, which will pointing, like it will show entire how many records you have, how many rows you have, okay, and what time it was created, and where it was created, by whom it was created, and what schema it was created. That is all about metadata. Actually, some people says that the columns names we call it as a metadata. That is one of the worst thing nowadays happen in the present situations. So many people think that this metadata C1, C2, C2 as a metadata. So I personally face that guys. Okay, sir, it is wrong, sir. Exactly, it is wrong, sir. So the columns also call it as the raw data only. So what is metadata means? Which will pointing your raw data. So let's say, for example, as I said, like image. So at where it was created, by which camera it was created, which lens they are using, at which region it was created, at what time it was created. This is all about a metadata, which will pointing your raw data. Got my point? Yes, sir. Now you got to notice what is raw data and what is metadata. So with the help of metadata, so Snowflake will pointing to your actual storage called S3 or Azure Blob or GCP, GCS storage, whatever it may be. So that's what actually. So that's why Snowflake we call it as a cloud data warehouse with the combination of any cloud vendors. Let's say, see how it will be. No, nothing will taken care by, sir. You don't take any accounts like that, sir. If you take the Snowflake account, Snowflake will deals with this AWS people, sir, or Azure people or GCP people. See here, let's say, for example, go to the snowflake.com and now start for free. Watch popular subscriptions. Start free. So start your 30 days free trial, Snowflake trial, which includes 400 worth of free usage, $400 worth of free usage. So now you can create your account name, for example, maybe classes 31. Ravi classes 31 at the rate gmail.com. And company, any name, your wish, like IBM. Role, any role you can select, BA, analyst, whatever it may be. And then click on next. There we have different dimensions, like a business critical or enterprise. Choose anything, no problem. Don't go with standard. It is the least version. Enterprise or business critical. Now select your cloud provider. Amazon, Azure, or GCP. If you select like this, Snowflake account will create. And for the storage, AWS people in the Singapore, AWS people will allocate storage and computing based on our requests. Actually, as a user, we don't want to connect with AWS people. We need to connect with Snowflake only. Snowflake will take care about it. Got my point? Yes or no? Any question, please ask me. So like this, we can get. Now you can came to notice that what is Snowflake. Snowflake is one of the cloud data warehouse database which will be work with huge and bulk of data maintained as a centralized repository. And it will store huge and bulk of data coming from different range of sources. And it will be work with a combination of any cloud vendor like AWS, Azure, and GCP. At backend, for compute for Snowflake application, a backend supporting storage is a cloud vendors like Azure, AWS, and GCP. Computer support is as from cloud vendor like AWS, Azure, GCP. Okay. So, but all will be defined with a virtual warehouses only, virtual warehouse and metadata. So computer will be defined with virtual warehouse concept in the Snowflake, whereas metadata will be pointing with the metadata to pointing to raw data in the Snowflake layer itself. Now, let's say choose AWS, for example, Snowflake with AWS computing temporary storage and permanent storage will getting. Now entirely we call it as a cloud data warehouse called Snowflake. Then why, sir? There we have a AWS having a own product called Redshift. There we have a Azure called Synopsys. There we have a GCP called Google BigQuery. There we have a Teradata called own cloud called Teradata. Then why, sir, we are going with Snowflake instead of going with their own products? So actually, first thing you need to remember, these guys are doing business. They are giving some resources, their computer resources and storage resources to their own products as well as a third-party products called Snowflake. Okay, Snowflake. So for that, it is nothing wrong in that first point. And the second point, instead of having their own products, why these guys are giving referrals to the third party? Why? Because they are working as a cloud computer resources, so that they working to the rental purpose, so that everybody asks means definitely they need to provide the resources to the third parties also. That's the second point. And the third point, instead of having these many data warehouse, cloud data warehouses like Redshift, Synopsys, BigQuery, Teradata, instead of having these many cloud data warehouses, why we need to go with a Snowflake only? Why we need to go with a Snowflake only? That will be discussed on tomorrow. Why on tomorrow? So please, do you have any questions? You can ask me. And then first thing, this is the first section. Okay, that's why I'm closing this much of earlier. I'm mostly concentrated on your questions only. Okay, so do you have any questions? You can ask me in any point. Okay, and then I'm requesting you once again, please fill that form. I already pinged that link in your drive. Please fill that form. Again, I'm sending that link. Okay, please fill that form. Please, everybody, please fill that form, and we will meet on tomorrow. Any questions? Please ask me. Thank you. Thanks for your time. Bye.